Hi, everyone. Let me know if you can hear me. Just type something in the chat. This is the first time I've been doing this with a new interface. I just want to make sure it works. There's about a 30-second lag between when you see me and when I see your responses. But um, wait just a few minutes. Um, can someone just type something in the chat, the text area there? Thanks. All right, well, just wait just a couple more minutes. There's about 5 people missing, it looks like, and I mean, this is the first time we're doing it, so I expect there to be a bit of confusion about it. But um, well, in the meantime, before I start doing some problems, let me just tell you a little bit about how the course works. I mean, I think you guys already understand because you should have looked at the syllabus. But the Tuesday class is what in the business is called asynchronous. It means it's something that you do on your own. And so we don't meet for the Tuesday class. I've got pre-recorded videos. And the pre-recorded videos, I discovered when I did this last semester that it's not that I go too fast, but that there's a lot of information packed in them. Okay, like in the classroom, I would stop, ask questions, people would ask me questions, but during those videos, I just go through the material at a constant rate, and so there's a lot there. So my point is that you may have to watch them more than once, or you may have to actually watch them, stop, and think about what I did, rewatch parts of it, even take notes during them as if you were in the classroom. And then, of course, you can ask questions during the live streams, which we'll have on Thursdays. And we'll proceed this way with the exception of the weeks of the test. Okay, so hopefully people have watched the videos that I gave you. There are 3. And I'm giving you those links in the emails, but also those links are on the Canvas site. So if you go to the Canvas site, for some reason you don't want to go through the emails, you don't want to search through them for the links for the videos that you should have watched, you can go to the Canvas site and the links are there. Now there might be more than I've assigned so far, but at least the ones that I've assigned are there, okay? And so you can watch them from there, and you don't have to go through your email. And what I'm going to do on Thursdays, and I'm going to start right now, is I'm just going to go over problems. And the reason I want to go over the problems with you is you can see them. There are actually only 4 of them, so I don't think this is going to be a very long class. We just don't have enough material for me to do a lot of problems with it. But I'll go through them and you can ask me, and this will be more like the classroom where you can ask me and I'll stop and I'll answer questions about why I did what I did and so on. And also, especially when it comes time to do physics problems with diagrams, the diagrams that you'll see in the lectures are finished diagrams. You don't see the steps that I took to draw them, and that's important. Okay, so let me just I gotta flip back and forth every once in a while to look at what's happening in the chat, and I just see a lot of people saying hi and love the waiting music. Yeah, just so you know that that's a picture of my dog's eyes. Okay, I might change them around as I go along. I might use different pictures and different music. The music won't be great because I have to use non-copyrighted music or music that's in the public domain. So don't expect the latest and best music, but it'll be music like that. Okay, so what I'm going to do today is I'm just going to do, I guess I have here 3 problems which are on converting. Okay, and they really are easy, so this won't take long. And then just 1 problem on the business of average velocity, which you should have seen in the last video, which was the video that introduced 1D kinematics. Okay, and so let's take a look at this first problem. Convert 100 kilometers per hour to MKS units. So the first thing is understand what's going on here. MKS units are the units we're going to use in this course. And the reason we want MKS is because all the formulas are based around MKS. If you plug in the numbers in MKS units, the answer will pop out in MKS units and everything will work out. If you mix units, things can go bad, okay? Later on in the course, I'll show you how you can sometimes get away with not converting, but for now, let's convert. And anyhow, the thing is you're going to have to convert in practically every science or medical based course, so you might as well know how to do it. So here's the first question. Let's take a look at that. Convert 100 kilometers per hour to MKS units. So the first thing you identify is what are the dimensions that are involved here, and the first dimension is kilometers, which measures length. Now, kilometers is not an MKS, it's not one of the MKS units, or it's not the MKS units for length. The MKS units for length is meters, okay? And you also have this HR, which is short for hours, okay? And hours, what does that measure? Time. Okay, remember there are three dimensions: length, width, time. Length, um, time, and mass. Okay, and the time unit that we're going to use is seconds, and so we want to convert the kilometers to meters, and we want to convert the hours to seconds. Okay, let me just take a quick look at the chat here. Oh, 19 people. Yeah, we're doing pretty good. Okay. Uh, all right, and let's do that. Okay, so convert. So the first thing you do is say, okay, well, 1 kilometer is equal to 1,000 meters. Okay, you're not going to have to know a lot of these conversion factors, and in fact, my third question, I'm going to show you how to look up a conversion factor using Google. Okay, but there's one. You should know that a kilometer is 1,000 meters. Okay, and 1 hour is 60 minutes, and a minute is 60 seconds. So if you do 60 times 60, that's 3,600 seconds. Okay, whoops, seconds, like that. All right, and you say, well, what am I going to do with that? So this is a little hard to draw using my whiteboard here, but we want to make a fraction. And the fraction, you see how the kilometers are in the numerator here? We want to make a fraction which is equal to 1 with the kilometers in the denominator. And so we're going to take this and we're going to divide one side by the other, and we want the kilometers in the denominator. And so we'll do 1,000 meters, sorry, divided by 1 kilometer. Let me space that out a bit so you can see it. Okay, like that. All right, and this is equal to 1. That fraction there in brackets is equal to 1. Okay, and so you can always multiply by 1 and it doesn't change your answer. And then the other one is 1 hour is 3,600 seconds. Notice the hours in the denominator, and so we want the hours in the numerator when we make the fraction. And so this fraction is going to be 1 hour in the numerator divided by 3,600 seconds in the denominator, like that. And this fraction is also equal to 1. So here's our original number, 100 kilometers per hour. By the way, that's the speed of a that you drive on the highway. If you ever drive in Canada, it's 100 kilometers per hour. It should turn out to be about 55 miles per hour. And so we can multiply by this fraction because that's equal to 1. It's like nothing has changed if you multiply by 1. And we can multiply by this fraction like that. And that's because it's also equal to 1. And now what? Well, let me do this in place here. You see that kilometers there? That kilometers, which is in the numerator, cancels against that kilometers in the denominator. And that hours in the denominator cancels the hours there like that. So we could just get rid of that. I'll do that right here like that. So that cancels that. And that cancels that like that. And so we just get this. All right. And notice that the only units that are left are meters and seconds on the bottom there. And you just take your calculator and you take 100 multiplied by 1,000 divided by 3,600. So that's like 100 divided by 3.6. Let me do that on my calculator. You can't see me using the calculator, but I am. I'm just doing 100 divided by 3.6. And it's this number right here. Okay. And I've got way too many significant figures there, but there it is. It's 27. Let's round off to 3 significant figures. 27.8 meters per second. Okay, so that's the answer. Now this is very similar to the one I did in my lecture. And so I think I don't remember, but I think I did 50 kilometers per hour. But there's the same thing done with 100 kilometers per hour. Very typical conversion. And so you learn very quickly that to convert from kilometers to hours to meters per second, it's just effectively like dividing by 3.6. Okay, so on a test you don't have to show all this, because it's pretty trivial. Just divide by 3.6. Okay, let me look quickly in the chat here, and like I said, there's a 30-second delay, so if you have any questions, type them into the chat. I might go on to the next question so that I don't waste your time. But I'll look in the chat every once in a while, and if I see stuff in the chat, then I'll answer that. Okay. So if there's any questions there, then oh, there we go. Sorry, there was a bit of a lag on my side. All right, there's one. Okay, so here's the next one. This one's a little bit more involved. Convert 7,500 cubic centimeters. Now, I can't do exponents in this whiteboard, so this caret here, you'll see me in a lot of these lectures, whenever I have to do exponentiation, I'll just put that little caret sign. It's like on your keyboard above the number 6, okay? But all that means is like centimeters cubed, okay? Let's convert that to MKS. Now, to be honest, we won't have to do a lot of those conversions like cubes and things like that this semester. Next semester, we'll have a lot of them. And there will be a few this semester, so now's the time to actually look at this, okay? So we have centimeters here, and we want to convert to MKS units. And you say, well, what's the dimension that centimeters measures? And it measures a length, right? Okay? And whenever you have a length cubed, like this, that's actually a volume, all right? So centimeters cubed is a volume. And like I said, we won't need volumes this semester. I don't think they come up at all, actually, but they come up a lot next semester. And there's other squared units and cubed units that come up this semester, so we do need to have those. But this is a volume, okay? It's like a length, a width, and a height. So a centimeter by a centimeter by a centimeter is a centimeter cubed. We have 7,500 of these, but we want to convert to MKS, okay? And you say, well, what's the MKS unit for length? I know we have a length measured 3 times, but it's just a length, and the answer is it's a meter. Okay, so now you say to yourself, okay, how does centimeters convert to meters? So which is the bigger unit? So you should know this from, you've probably studied the metric system, but you should know that 1 meter has 100 centimeters in it. So the bigger unit is the meter. So start there. You go 1 meter is equal to how many centimeters? 100 centimeters, like that. Okay, so you got 1 meter equal to 100 centimeters. By the way, you could also do this. I'm not going to do it here, but just you might have seen this. You might say, well, 1 centimeter, what's that in meters? Well, that's 0.01, a hundredth of a meter. That's perfectly fine. The two are totally equivalent to one another. Basically, all you do to get this from this is you divide both sides by 100. But I like doing it this way. Take the bigger unit and express it in terms of how many of the smaller units you have. And there it is. So you have 1 meter is 100 centimeters. Now, the next thing we want to do is we want to form one of these fractions. Just like we did up here, we want to form a fraction that's equal to 1. And so over here, we're going to say, okay, how are we going to do this? Well, the centimeters here, there's nothing in the denominator. It's all numerator here. So that centimeters is in the numerator, okay? So we want the centimeters in the denominator. Whoops. There we go. we're going to form a fraction. Here, I won't put the numbers in like that. We want to form a fraction where, this part here, that's the numerator divided by the denominator there. And you say, okay, well, that's centimeter, that's in the numerator, so we want the centimeters in the denominator. And I haven't finished it yet, so I've got to put some numbers in there first, or yet. And in the denominator, we want meters. So if we do it this way, if we put meters on top and centimeters on the bottom in the fraction, these centimeters will cancel those centimeters, okay? And now we have to make this equal 1. It's not equal to 1 right now, but if we say, look, 1 meter is 100 centimeters, like that, we formed a fraction that's equal to 1, okay? Let me quickly look at the chat here. Yeah, no one's asked any questions. This is pretty easy stuff, I hope. And so there we go. We've got something which is equal to 1, okay? Now, the original number was 7,500 centimeters cubed, okay? Now that cubed is going to be important because if I multiply this by this number here, okay, the centimeters cubed, let me rewrite that. So what do you mean when you cube a number? Like if you have 3 cubed, what you mean is 3 times 3 times 3. If you have 5 cubed, it's like 5 times 5 times 5. If you have centimeters cubed, what you mean is centimeter times centimeter times centimeter. I won't put the x in there just to make it easy. Okay, so we got 3 centimeters. Okay, but over here we have only 1 centimeter in the denominator. So this fraction here will only cancel out 1 of them. We want to cancel out 3 of them. So you know what you do? You just multiply it 3 times. Let me see if I can do this. Copy, paste, and paste. Okay, So see how this is different than the previous one? In the previous one, I just had 1 kilometer in the numerator, 1 hour in the denominator. It was easy. But here I actually have, because it's centimeters cubed, I actually have 3 centimeters in the numerator, so I have to cancel out 3 centimeters in the denominator. And what do you introduce in its place? You introduce a meter, and then another meter, and then another meter. You wind up introducing a meter cubed. Okay, so I could actually, well, let me show you this on the next line. So the next line, like this, one of these centimeters, say that one, will cancel this centimeter, and another one of these centimeters cancels that one, and another one of these cancels that one there, like that. And there you go. Notice there's 3 meters, so you get meters cubed as your answer. So so what you would do on your calculator is you would take 7,500, divide by 100, divide by 100 again, divide by 100 again. Okay, and what's that going to give us? Let me do that. That's like dividing by a million. 1, 2, 3, 4, 5, 6. All right, copy. There we go. And we got a meter. That's that meter. And then we got another meter, and then we got another meter, and 3 meters we could write as meters cubed. Okay, so there you go. This is a more complicated example, and let me see if there's any questions in the chat. Not looking pretty good. All right. Okay, so that's question number 2. So question number 2 just adds this extra complication. What do you do whenever there's an exponent on one of the units? All right. And the last one I'm going to do, to be quite honest, we're not going to do conversions between like pounds and stuff like that. Okay. The reason I'm showing you this is because since I'm teaching you unit conversion, I might as well show you how to do unit conversions right across the board, no matter what class you're in, or in real life or whatever. And you say, okay, we got pounds and we want to convert to the MKS units. Now pounds measures weight, okay? And so we have like pounds. So, and what we want to convert to are the MKS units for mass are kilograms, all right? And so we need some numbers there to do the conversion. You go, where am I going to get those numbers? Well, here's where you can get them. Let me just quickly switch windows here, and there you go. You should now see Google. Okay, let me see if that's coming up. Should be coming up. Yeah, all right. You should see the Google page there, like that. And you could literally just go to Google and type in the Google bar, convert the one unit to the other unit, calculator, and it tells you exactly that conversion factor. So you don't have to really memorize these numbers. You could even do between like centimeters and meters. I don't know, like on a test, you forget how many centimeters are in a meter or something like that. Google will immediately give it to you. Just put like convert the first unit to the second unit, and it'll tell you, 1 pound is equal to 0.453592 kilograms, like that. Okay, so let's write that down. Well, you'll see me. You're not seeing me writing it, but you'll see it in a second. All right, let me switch back to my whiteboard. Where is it? There it is. Okay, so all I did was I just cut and paste the numbers that I got out of Google. There they are. All right, and so 1 pound is equal to that fraction, 0.453 kilograms. And so now, what do we want to convert? Well, we want to convert 13 pounds to kilograms, like that. And we're going to form our fraction. There you go. Okay, there's our fraction. And we want pounds in the denominator here to cancel out the pounds in the numerator there. So we'll put the 1 pound in the denominator there. We'll put the number of kilograms in the numerator there, like that. So that was very easy to do. And, the pounds will cancel. Like that pounds will cancel that pounds. Okay. If you accidentally make the fraction the other way around, it won't cancel. So make sure that the pounds cancel, and bring out your calculator. And so it's going to be 13 multiplied by this number right here. And give me a second. I might as well do that for you. Multiplied by 13. And there you go. There's your answer. Okay. Too many significant figures, but that's okay. I'm not really that worried about the significant figures. The point of question number three, you said, I just said a minute ago, we're not going to be using like pounds and inches and things like that. The point of question number three is to just show you that this method will work no matter what units you're working on. Okay, so I think that's enough for unit conversions. I'm pretty sure that you guys are probably even bored right now. You've probably done this before, but just for completeness, I wanted to do that. Okay, let me look to see if there's any questions in the chat, and if not, what I'm going to do next is I'm going to do some examples. Well, actually, just one example from 1D kinematics. Okay, so in 1D kinematics, let me describe that. I've just got one problem here because right now I didn't give you enough stuff on kinematics that we can really do a lot. Okay, so just to kind of refresh your memory from the video, what kinematics is about. Kinematics is a mathematical description of motion. Okay, so you're not asking the question, why did something move the way it did? I don't know, like you're watching a car going down the street and it stops. Okay, you're not saying, well, why did it stop? What caused it to stop? That's called dynamics, and we'll study that when we get to Newton's laws. All we want to do is just mathematically describe how that car stopped. Like we want to put some numbers on how it stopped. And so the kinds of things that kinematics is worried about is like, where is the car at all various times? How fast is it going? What's its velocity at different times? And what's its acceleration at different times? Okay, so that's what kinematics is all about. And in the lecture that you saw in my last video was basically I needed to introduce the idea of average and instantaneous velocity. So instantaneous velocity is obtained from average velocity by making your average smaller and smaller and smaller. But you guys, because you can't do calculus, I really can't give you a much better definition of instantaneous velocity, except it's an average velocity where the time interval is extremely small. Okay, so the question I have right now is just a question for average velocity. I see someone just chatted something in the text chat there. Let me see what he said. On the tests and or quizzes, will we be given a list of conversion? No, the tests are open book, right? And so if you have a conversion that you have to make, how would you do it? I just showed you in question number 3. You could just look at all the conversions yourself. So no, I mean, there's no reason. Will you be given a list of conversions? No, there's no reason to give you a list of conversions because you can obtain them from Google, just the way I showed you. I hope that answers your question. I mean, I think you won't have any problems with this, honestly. Okay, so if you see, like, if I say convert from kilometers per hour to meters per second, and you forget how many kilometers there are or how many meters there are in a kilometer, no problem. Just go to Google and type in convert km to m, and it'll pop up. It'll just give you the number. It'll say 1 kilometer is equal to 1,000 meters, and that provides the fraction for you. Okay, so I think that's how you'll do that question. All right. If that didn't answer your question, you can always ask again. But let me continue now and with this other problem here. Okay, so let's take a look here. I say a car is found to be at the following positions at the given times. Okay, so actually you're going to do this in the lab, and in the lab, of course, you don't have a car, you have a glider, and this glider is going to glide across a linear air track. This is a kind of a triangular shaped track which pushes air so that the glider glides smoothly across it. Okay, and there's very little friction. Okay, and in my particular instance here, this car at time t equals 0. So if you have like a stopwatch, and you start at t equals 0, the car is 2.5 meters from some reference point, from the origin. You remember from the lecture, I chose a tree. It depends, on your situation. You just pick a reference point and you say, I'm going to measure everything from this reference point. This is what I'm measuring everything from this tree, or on the linear air track from the, maybe one side of the linear air track. It doesn't matter as long as you're consistent throughout. So you say, well, how did you get that 2.5 meters there? That 2.5 meters, this is an experiment. It was just like, at t equals 0, when my stopwatch said 0 seconds, I measured the distance from my reference point, the origin, to the car, and I found it to be 2.5 meters. Okay. A second later, that's when my stopwatch says 1 second, the car is at 3.1 meters. And then at 2 seconds, it's at 3.9 meters. And then at 3 seconds, it's at 4.9 meters. Okay. So if you ask the question, where is the car at zero point 0.5 seconds? You don't know. You just don't have that number. Okay. And so you can't get this idea of an instantaneous velocity. You can't get an instantaneous velocity out of this, because the instantaneous velocity, those intervals would have to become infinitely small, and you just don't have that data. Okay. So what I'm asking in this question, and it's like a question that you would have on a test, or probably on the little assignment that I give you on the weekends, I'm going to ask you, well, what is the average velocity during an interval of time? Okay, so question A is, what's the average velocity during the interval 0 seconds to 1 second? Okay, so what I'm asking for there is average velocity, and I can't do a V with a bar on top, but technically that should be like a V with a bar on top, because the bar on top means average. And whoops, I misspelled velocity. There you go, velocity. And the answer is, it's delta x. That's the change in delta, just means the change in position. I'll make that clear when I put in the numbers, divided by delta t. And delta t is the change in time. Okay, and this is an average. It's like, how far did you travel, and how long did it take you to travel that time? Okay, so for the part A, you would just put in delta. So delta means, where did you end up? That's your final. That's the 1 second. So where are you, or where's this car at 1 second? At the 1 second point, it's at 3.1 meters. So there is, let me put a space in there like that. So there is one part of the delta x. Okay, so it's at 3.1 meters. Okay, minus, where did it start? That's, where is it at the 0 second? So that was 2.5, and let's close the brackets there, divided by this part here. This is your delta x. So just to make it very clear what that delta x is, it's like your final position minus your initial position. So final minus initial, that's how far you traveled. It traveled, 3.1 minus 2.5, which I guess is 0.6 meters in time delta t. And for time delta t, you do the same thing too. Okay, you say, what was my final time on my stopwatch? That was 1 second. Okay, and what was my initial time on my stopwatch? Well, that was 0 seconds, like that. And there you go. So this top piece here, there's your delta x, and there's your delta t. And when you calculate that, this gives you the average velocity. And I think I can do this in my head. That's 0.6 divided by 1 at 0.6 meters per second, like that. Okay, so during that time interval from 0 to 1 seconds, the car was traveling at 0.6 meters per second. All right, not too fast, not that fast at all. All right, and now I ask you to do it again. Okay, so the formula is always the same, but now our time interval is from 1 second to 2 seconds. So the final is what is the 2 second value. That's this value right there. Okay, so at 2 seconds, the car is at position 3.9 meters from the reference point, and 3.9 meters, like that. So there's your final position. Your initial position is, where are you at 1 second? Well, at 1 second, you're at 3.1, like that. And the delta t, that's, your final time. Well, your final time was 2 seconds. Your initial time, this is like the time that you would see on your stopwatch if you had a stopwatch. So the initial time, the interval started at 1 second, and it ended at 2 seconds. So there it is. And again, I made my numbers easy. So this is going to be 0.8 meters per second. Okay. All right. See if there's any questions with this. All right, I don't see any new questions in the chat. Let me continue. All right, and so let's do the average velocity during the 2 to 3 second interval. Same thing. I think you got it by now. So I'll go a little faster here. So where is it at 3 seconds? At 3 seconds, it's at 4.9. And at 2 seconds, where is it at 2 seconds? Its position at 2 seconds is 3.9. Okay, 3.9. And divided by the time interval, well, you end at 3 seconds, you started at 2 seconds, so it's going to be 3 seconds minus 2 seconds like that. And that's going to equal 1.0. Let me show you how the units work. They're MKS units, so your answer has to come out at MKS. But you got meters on top, seconds on the bottom, so it's meters per second, like that. Okay, so there you go. Now, before I answer question D here, hopefully that was pretty easy. Tell me what's happening to the velocity over time. So during the first 1 second interval, that's from 0 to 1 seconds, the car is going at 0.6 meters per second. During the next time interval, so it's another second, but it's a later second, between 1 to 2 seconds, okay, the car is going at 0.8 meters per second. And then from 2 to 3 seconds, the car is going 1.0 meters per second. So you'll notice that the car starts off slower, 0.6, and then it speeds up to 0.8, and then finally it speeds up to 1.0 meters per second. So this car isn't traveling at constant velocity, it's actually speeding up. And I don't have a question on this, but that's called acceleration. When your velocity doesn't remain constant, it gets faster and faster and faster. Well, then you've got acceleration going on. Now, I'm not going to ask you guys to calculate average acceleration. You'll do that in the lab, but it's kind of complicated because if you calculate average acceleration on top of average velocity, it just it leads for some complications which are better dealt with in the lab. Right now, it's more important that you just have this idea of what an average velocity is. It's a velocity over some time interval, and the time interval is between 0 to 1 second, and then 1 to 2 seconds, and then 2 to 3 seconds. But the interval doesn't have to be just like, these 1 second intervals. I could say, what's the average velocity over the entire trip? And that is my question D. What is the average velocity during the entire trip? Now, the entire trip starts at 0 seconds and it ends at 3 seconds. So I want the time interval from 0 to the average velocity over the time interval from 0 to 3 seconds. And so let's do that. All right, exactly the same as above, but now the final time is 3 seconds, that's 4.9, minus the initial position at t equals 0 seconds, and that's 2.5, like that. And there's your delta x, okay? It's literally the delta x over the entire trip. So it's the whole distance traveled from that 2.5 meters to the 4.9 meters. And then divided by the time interval. Now the time interval now isn't just 1 second. You end up at 3 seconds. You started at 0 seconds. So the entire time interval is 3 seconds long. Okay? And what's that going to be? Let me do that on the calculator. I'll give you the answer in just a second. So 4.9 minus 2. Oh, I made a mistake, sorry. 0.9 divided by 2.5. Okay, divided by 3, and that's equal to 0.8 meters per second. All right, there you go. There is the average velocity over the entire trip. Now, does that make sense? Well, you started off slow, started off at 0.6, you sped up to 0.8, then you sped up to 1 meter per second, and you could see that that 0.8 is right in the middle. Okay, and so this is an average velocity, but it's an average velocity over the entire trip. Last thing I'll say, just to make clear this idea of an instantaneous velocity, you simply cannot get an instantaneous velocity out of this data, because the whole idea of an instantaneous velocity is that you want to make that delta t smaller and smaller and smaller, so that you could say, what was my velocity at this instant? And what you mean by an instant is one point in time with just a very small delta t around it. But you can't make your delta t smaller than 1 second, because each one of those time intervals there are 1 second. So you don't know where the car was at half a second, you don't know where it was at 1/10 of a second, you don't know where it was at 100th of a second. And in the absence of being able to shrink that delta t to smaller and smaller values, you just can't get an instantaneous velocity. Which means that in the lab you don't have instantaneous velocities, you just have average velocities. But that's okay. In the lecture, when we start doing 1D kinematics with constant acceleration, that is things that fall, like things that fall, which is going to be the next video watch next week. Things that fall, they accelerate at a constant velocity, constant acceleration, and you can actually talk about the instantaneous velocity at various times. Okay, so short lecture, I know, but there's just not that much. Well, 45 minutes. There's just not that much that I can uh, really pack in right now. There's not much more to it than that. So over the weekend I'll create a quiz, but Monday I'll not a quiz. I should a little assignment. I'll probably have like 2 or 3 questions like this, and at least by Monday, I'll email you guys and I'll say do this little quiz, and this way you can practice exactly what I showed you right now. You can practice it for yourself. Okay, and it'll be graded and it'll be part of your course grade. Okay, so that's it. If there's any questions, I'll hang out for about 5 more minutes and answer any more questions that you have. This stream, if you want to come back to it later, it'll be online, okay? And so you could just go to the. You know what? I think what I should probably do is later today I'll just email you the link for the stream, okay? And then you can take a look at it. All right. So if you missed anything, well, while I was lecturing today, or I don't know. Try to make these because this is the only way. Not the only way, but this is a good way that you can ask questions um, as I do as I show you how the problems are done. So try to make these. But if you should miss one of these live streams, you can always watch it on your own afterwards. All right. So any questions? I see. Thank you very much. Have a good day. Yeah, you too, Anthony. Okay. Wait a few more minutes and you guys can leave if you're done. Just pop out of it, and then when the number goes down to 0, I'll hit end stream. Thanks everyone. All right, I'm seeing the numbers go. Bye bye. All right, I'm just going to end the stream, guys. It doesn't seem that there are any more questions or anything else. Oh, wait, there's one. Sorry. When is the quiz due? Well, it's actually an assignment. It's an assignment. It'll show up as quiz because that's the way Canvas calls them. I'll probably give you a week. All right. Yeah, thanks, Nick. I hope these things are useful. Like the combination of the videos that you watch, and then these live streams where they're more casual. I hope they'll be quite useful to you. All right, down to 11 people. Any more questions? All right, bye bye.